I want to travel by train from London to Plymouth, and I want to get there for 5 o'clock in the afternoon. Here is a train timetable of all the times of the trains. If I want to arrive in Plymouth for 5 p.m, which train should I catch? If I want to arrive in Plymouth for 5 o'clock in the afternoon, I need to look at all the arrival times into Plymouth to find the train that arrives just before 5 p.m. But there doesn't seem to be one. The times in timetables are written in the 24-hour clock. So midday is 12, 1 o'clock is 13, and so on. So let's have another look. Five o'clock in the afternoon on the 24-hour clock is 5 hours more than 12. So we're looking for a time of just before 17 hours. And here it is, arriving at Plymouth at 16:29. That's 29 minutes past 4 in the afternoon. And it leaves London at 13:06, and that's 6 minutes past 1. So that's the one to catch. Now, how long is the journey from London to Plymouth going to take? You can work it out from the timetable. To calculate the journey time, we need to work out the difference between the arrival time of 16:29 and the departure time of 13:06. These are hours and these are minutes. So the difference between them is 3 hours and 23 minutes, which is how long the journey takes. If the train journey lasts 3 hours and 23 minutes, and the distance from London to Plymouth is 240 miles, what is the train's average speed for the whole journey? Speed is the distance covered divided by the time taken, which in this case is miles divided by hours, or miles per hour. Now, we know the distance from London to Plymouth is 240 miles, and the time taken is 3 hours and 23 minutes. So now you can work out the average speed of the train. We need to convert 3 hours, 23 minutes all into minutes. We know that 1 hour is equal to 60 minutes, so 3 hours is equal to 180 minutes plus the 23 minutes, and that gives us a total of 203 minutes. So now we can work out the average speed. That's the distance, 240 miles, divided by the time, 203 minutes, which is 1.18. Now, that's an odd result for the speed of a train, and that's because it's in miles per minute. We need to multiply by 60 to give us the answer in miles per hour, and that's 70.9 miles per hour. I could travel from London to Plymouth by plane, which should be quicker than the 3 hours, 23 minutes it takes by train. But is it? Here is the plane timetable. There are 2 flights a day, at 9:40 and 19:05. And they both take 70 minutes each. So what's their average speed over the 240 miles it is from London to Plymouth? Speed is distance divided by time. So that's 240 miles divided by the 70 minutes, and that equals 3.43 miles per minute. If I multiply that by 60, that gives me 205.7 miles per hour. That seems much faster than the train, but is it? There's more to the journey than just a 70-minute flight. It takes 40 minutes to get from the centre of London to the airport. And it takes about 40 minutes to check in. And once you're in Plymouth, it takes about 30 minutes to collect your bags. And another 20 minutes to get to the city centre. So what's the average speed of the whole journey now? The average speed of the whole journey is the 240 miles divided by the total time, which is 40 plus 40 plus 70 plus 30 plus 20, and that gives me a grand total of 200 minutes. So if we divide 240 miles by 200 minutes, that gives us a total of 1.2 miles per minute. If we multiply this by 60, that gives us an answer of 72 miles per hour, which is pretty much the same speed as the train. A handy way of representing a multi-stage journey like this one from London to Plymouth is to use a distance and time graph. Up the vertical axis is the distance from central London to Plymouth, and along the horizontal axis is the time taken, and that is 3 hours and 20 minutes. For the first 40 minutes of the journey, we're travelling from the centre of London, and that takes us 40 minutes to travel just 10 miles. Here are the other stages of the whole journey. Use the information to complete the graph for yourself and calculate the average speed of the whole journey. You should get something that looks like this. This part here is the 40 minutes we travelled to the airport, just 10 miles. Next is the check-in, and it takes us 40 minutes to go no distance at all. Next is the 17-minute flight, and this takes us up to this point here. Then there's 30 minutes to collect the bags in Plymouth, and 20 minutes for the final 10 miles of the journey that takes us into the centre of Plymouth, which completes the 240 miles in 3 hours and 20 minutes. To work out the average speed of the whole journey, join the two ends of our graph like this. So from 1 hour on the horizontal time axis, look for the corresponding point on the distance vertical axis, and that gives us an answer of just over 70 miles. So the average speed for the whole journey is just over 70 miles per hour. To drive the 240 miles from London to Plymouth, I'll need plenty of petrol. And the price of petrol today is 110 pence per litre. And I need to work out how much the journey will cost. To get from London to Plymouth, I can use the motorway or the ordinary roads. On the motorway, my car does 70 miles per hour and it does 30 miles for 1 gallon of petrol. If I go on the ordinary roads, my car does 50 miles per hour with 40 miles to 1 gallon of petrol. So how much do these two alternatives cost? And you'll need to know that 1 gallon is equal to 4.5 litres. The first thing to sort out is the units. Although we buy petrol in litres, we still talk about petrol consumption in miles per gallon. If 1 litre costs 110 pence and there are 4.5 litres to 1 gallon, to work out 1 gallon of petrol, we multiply 110 by 4.5, and that gives us an answer of 495 pence. On the motorway, my car will do 30 miles on 1 gallon of petrol. So the cost for 1 mile is 495 pence divided by 30, and that's 16.5 pence. For the whole 240 miles, that's 16.5 pence times 240, and that equals 3,960, or £39.60. On the ordinary roads, my car will do 40 miles on 1 gallon of petrol. So for 1 mile, that's 495 divided by 40 equals 12.37 pence per mile, multiplied by the whole journey of 240 miles, and that equals 2,970 pence, or £29.70. But that's nearly £10 cheaper. This is the busy M25 around London. Depending on how much traffic there is, they can change the speed limit. What effect do you think this has on the flow of traffic? The faster the traffic, the bigger the gap each driver leaves in between the car in front, in case they all have to suddenly stop. When the speed limit is reduced, cars can drive closer behind each other so more cars can use the road.